Good morning, 7th grade. Actually, it's afternoon because it's after lunch, right? You have a foldable in front of you, and I wanted to just give you some notes to put in your journal regarding theoretical probability and experimental probability. You did a phenomenal job basically understanding the difference between the two. So the way you are going to fold that is like this. And all I want to do today is just give you something that, well, one, to practice it formally, and to have something in your notebook for you to use as a study tool, okay? All right, so basically theoretical and experimental, and we're going to go into detail. Okay, theoretical, a lot of you got this, okay, is what should happen, right? And you always have to remember that to find that, we always did the favorable over the possible. Okay, so if it's what is the theoretical probability of rolling a 1? So on a dice, the favorable that I'm looking for, there is one of them. Okay, if I were going to roll a 2, there's still just 1 2 and just 1 3, but the total possible is 6 sides. Okay, and the way to, if you want to do it layman terms, right, kid language, it's what you want over the total. Okay, all right. The other thing that we've been talking about, especially in the event that we did yesterday, we saw that your experimental probability got closer and closer to the theoretical with more trials. But the one thing that we didn't really talk about was that the probability of an event is always going to be between 0 and 1, right? If you do 10 trials, or I'm sorry, let's say a coin, heads and tails. The probability is 50% or 0.5 for each side, and they both add up to 1. It can never be 150%. So always remember that. This is very, very important. It must be between 0 and 1 or 0% and 100%. And as you saw in our experiment yesterday with the spinner, you notice that they always added up to 100%. So if it was 60% yellow, it was going to be 40% blue. 30% yellow, 70% blue, okay? So it can never be above 100%. Very, very important. On the other side, so what is experimental probability? And the only difference to find that event is we find out how often it occurs divided by the number of trials, how many we did it. And that bottom number, remember that we had to add, a little thought box, add number of trials, okay, for total. I'm sorry, there we go. Okay, we used the word total a lot yesterday, but it's basically the number of trials. Okay, well, let's put it into action. Let's go down to the theoretical probability. Okay, now actually what we're going to do is an example of calculating theoretical probability and experimental probability. Okay, so we have a frequency table, we have a dice. This is the number, so the side 1, the side that says a 2, the side that says a 3, the side that says a 4, and so on and so on. Sometimes the dice can be a little bit confusing because you think that it's going to be 1 time, 2 time, but this is just the face of side. Okay? The frequency, sorry, I'm going to expand that. The frequency is number of times event happens. Okay? So in other words, out of my experiment, we need to find the total, and they even give it to us right here, okay? But always add that up anyway, just to make sure. So we actually did the experiment of rolling this dice 50 times, okay? And obviously, we rolled a 3 a lot more than any of the others, okay? Even the 3, I rolled 50% more, or 100% more than the 2, okay? All right, so what is the experimental probability of a number that is greater than 3. Think about that. I need to find how often it occurs divided by the number of trials. And I found out the number of trials, which is 50. Okay? But I need to find out how often it occurs for a number that is greater than 3. Okay? So we need to add these up. So 9 plus 11 plus 8. And that equals 28 divided by 50. And I can reduce by 2, can't I? That's right. So divide both by 2. And please write that number, because sometimes we use different numbers in our head. And that gives us 14. Think of 2 quarters divided by 2 is a quarter. Okay? And if I'm going to do the math for you. And it's 56 hundredths. And when we say the name of the place, we know that that is going to be a percentage. We have the tenth and the hundredth. I move my decimal to the right to convert it to a percentage. You don't have to, but especially if your answer choices are in percentage format, you're going to want to convert those, okay? All right, let's look at the theoretical probability. I want to know the probability of a number that is greater than 3. This is what I want to happen, or what should happen, divided by your total. Okay? The total possible, remember you can always freeze the screen, okay? The total possible is 6 sides, right? I don't have to have it 50 or anything like that. It's just 6 sides. So what I want is how many? 1, 2, it can actually happen 3 different times. And when we convert that, right, to 1/2, because literally half of the numbers are greater than 3. And we know that when we do the math, we can do top dog is it's actually 0.5. You don't need that 0 there. Sorry, I was going to write 50%. And when we convert that, it is 50% or half. Okay? So in our experiment, our experimental data was actually a little bit greater. It happened more than our theoretical data. Okay? Now, we can actually use the complement. So what is the probability of a number less than 3? What I love about this, so the complement is the number that makes it add up to 100, especially for an experiment. If we don't have to do all the math again. If we found it that what was greater than 3, less than 3 is what it makes to add up, so 44%. In other words, the complement is the number that makes it add up to 100. Okay? What is the complement for theoretical? That's right, 50%. Okay? All right, moving right along. Let's look at, has to do with when we roll dice and what they add up to. Okay, so, my bad. Okay, so if you notice that 2 dice, when we roll them, can add up to, like a 1 and a 1 can add up to 2. A 3, in other words, the sum of the 2 dice when I roll them, and I'm sorry I didn't have a pair of dice, and I'm struggling for time here on this video. We can have 2 and a 1, or 1 and a 2, okay? We have 2 and 2, 3 and 1, 3 and 1. There's a lot of different ways that we can have combinations. But if you notice, this is a frequency table. This is experimental. This is what actually happened. And actually, it kind of reflects what would happen in theoretical, because we can have a sum. Usually in the middle, you're going to have this bell curve when you're doing sums of 2 dice. Okay? All right. First, I want to go to the theoretical probability. And this is actually a combination. This is a sample space of what can actually happen. Okay? There are 36 different outcomes. And if you notice, I can have 10 3 times. Okay, so I want to know what is the probability of the sum of 10. And that equals how many times? Let's go ahead and highlight that. 3 out of 6 times 6 is 36. And think about your sample spacing. Remember, the probability of one dice is 1 out of 6. The probability of the other dice is 6. And what do? You multiply 6 times 6. In other words, there are 6 total outcomes, and you multiply to find your total sample space, see? So those charts on the wall, when you did the close between your group, you can apply it to dice, you can apply it to a spinner, you can apply it to anything to find that bottom number, okay? All right, so when we reduce that, if we divide by 3 on your numerator and your denominator, 3 divided by 3 is 1. 36 divided by 3 is 12. So the probability, and if we were to divide, we would get 83 thousandths. And when we convert that, we would move it to the right, and my new percentage would be 8.3%. Okay? And that matches. If it were 83%, that's closer to 1, isn't it? This is actually closer to 0. Okay? All right. Now, what is the experimental probability? So we want the probability of the sum of 10. And we look over here, this is actually what happened. Okay? So how many times did we roll it? We did the dice 60 times. Okay? And it usually will give it in the problem. If not, I need to add up how many times I actually rolled the dice. Okay? So the sum of 10, I had 5. And my bottom number is going to be the total number of trials. In other words, the total number of times that I rolled those dice. And if we divide by 5, excuse me, gives you 1, and 60 divided by 5 is 12. And that equals 0.083. Now, look at here. This is really interesting. Oh, sorry. This is one of the few times, very rarely, I am so sorry, I'm not paying attention. One of the first times that our experimental probability matched our theoretical. And that is our goal, right? Because remember that experimental is utilized for predictions, okay? And yes, we want our predictions to be as close as to what should happen as we possibly can, okay? All right, so you have a foldable. Let's put it in our last page. I'll let you glue it down since you know how to glue. So please, 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 just a little bit of glue. I will see you tomorrow. You do have a quizzes, so please make sure that there's only 7 questions. I want to see your work. I can't help you unless I actually see it, okay? Do you have to show all the steps? No, but please show me what you're doing.